Hey everyone, this is Matt Perez. I'm a Senior Applications Expert at SolidBox, and welcome to my course, Fusion 360, Getting Started with CAM. If you don't already know, CAM stands for Computer Aided Manufacturing. Just as the way that CAD stands for Computer Aided Design, its entire point is to make it easier for us to take our digital designs and make them a reality. Whenever I start these courses, I like to propose questions. What do you need? Now in this case, I broke it down into three broad topics: the basics of machining, the basics of design, and the basics of CAM. Now unfortunately, I can't teach you all you need to know on machining. It's really a hands-on process. You need to have some in-the-shop type experience. That's not going to stop you from doing CAM work and learning the process, but before you ever send a program to a CNC machine, you really should have had some experience on the shop floor throwing some chips. So we will talk about some of the basics of machining. Of course, we will talk about design because we're going to be doing some CAD work, and then we will talk about the basics of CAM. Now keep in mind that this is a beginner course. I will mention some more advanced topics, and if those appeal to you, I highly suggest that you carry on in this learning path. You learn more of the intermediate and advanced topics inside of CAM. Now when we talk about basics of machining, and again, this is something that you need to have some hands-on knowledge with, but there are three broad topics that I want to talk about: feeds and speeds, fixturing or holding your part, and tools. Feeds and speeds are hopefully what they sound like. Feed rate is how fast the tool is going to be moving across your part. The speed is the rotational speed of the tool itself. So when you start a new tool path, some defaults come in from whatever tool you select, and you can see in this image here that we have 7640 for the RPM of the tool. Its surface speed is 304 meters per minute. And then you also notice some other parameters here, things like ramp spindle speed, cutting feed rate, feed per tooth, lead in, lead out feed, and so on. So Fusion gives us a lot of control over these. And this in the background is HSM Works, and it's built very nicely into Fusion 360. It's one of the easiest CAM programs that I've ever used. But when we talk about these values, there is a lot of understanding that needs to go into there, and I'll touch on that in just a second. The second image is a part being clamped down to a table. Now the reason this is important is if you've ever machined anything, you know that it's very important to know how to hold the part. Now if you design something that can't be held in the machine, it can't be clamped down, it can't be held with a fixture, it's going to be nearly impossible for you to manufacture this part. Now I have done parts where I have used double-sided tape down to a table and gotten away with it. There are instances where they use vacuum tables. Some rapid CNC houses like Protolabs a lot of times will glue parts down, and then the glue can be melted or heated up, and that's a way that they can get away with machining some very complex parts. But for the most part, before you create a program, or really before you create your design, you need to be thinking about how you're going to hold it to manufacture it. And the last main topic is tools. And the reason that this is important is because hopefully if you're taking this course, you already know that there are cutting tools that are going to be cutting the material away. But there's a lot of variability that goes with those tools. Now, if you're getting them from a specific manufacturer, they will oftentimes give you very specific information about how fast the tool can spin, how fast you can move it, how deep you can plunge it into the material, and all that type of information. Now, your specific machine, the type of coolant that you're running, the type of material you're cutting, all those things are going to factor in. And again, this is where that real world experience is going to help.